So utility will be given questions as follows. We are told that Jacob's utility function is given by 10x, 2y. The price is 10 kwacha. The price of y is 5 kwacha. The income is 150. So we want to do three things. Number one, find the optimal bundle. Number two, graph. Number three, write the equation of the budget line. Of course, the order is misplaced, but we can do either of them in the way we have learned it. So I'll beam the question here again. So in this case, our objective function is as follows. M is equal to price of x plus price of y. So this is 150 is equal to what? 10x plus 5y. So to sketch this, our y is here, our x is there. So it means it will cut the y. 10 into 150, that is 30. So we put 30 here. 5 into 150. Then 10 into 150 is 15. So we put the 15 there. So what basically we want to find is where the indifference curve kisses the budget line to optimize consumption. So what is the optimum bundle? Marginal utility of what? X over the price of X as equal to the price of Y into the marginal utility of Y. So in this case, our utility function is what? 10x to y. So the marginal utility of y, we're going to differentiate. Let's have the marginal utility of x. Our dummy, what's our dummy? What is our dummy when differentiating with respect to x?
Y.
What are we differentiating? 10x2, which becomes what?
20y.
20x. Then the marginal utility of y, what are we having? Who wants to help? Who wants to try to differentiate? Who wants to differentiate for us? Which one is our dummy?
X.
Our dummy is x2. Then we're going to remain with 10y. 10y, when differentiate it, what's the derivative of 10y? Simply 10. So where there is MUX, we're going to put what? 20xy. Where there's MUY, we're going to put what? 10x2. We divide both sides by what? The prices. The price of good x is 10. The price of good y is 5. You can cross multiply if you want. 10 times 10x is 100x2. 5 times 20x is 100xy. So what's common throughout? There's 100 and there's an x. So you can divide 100x on both sides. And divide 100x and 100x. What remains inside? X is equal to y. You substitute this x is equal to y into our optimization problem, which we had initially. Okay. So where there is X or where there's Y, you put the other letter. So if X is Y or Y is equal to X, you're simply saying our function now becomes as follows. So here where there's X, we're going to put a Y. Simply means that we're going to have 150 is equal to 10Y plus 5Y. This means we're going to have 150 is equal to 15Y. When we divide both sides by 15, our Y therefore is equal to 10. So since X is equal to Y, meaning the same applies, that 10 is X, 10 is Y. So you're going to put a 10, and you're going to put a 10. And you will be smiling, getting your 10 marks for that. So this question came twice. So although if you're going to follow this, it's a very long cut that was used here, the Lagrangian function.
Sorry, Mr. Collins, can I take a screenshot for?
So our final answer is Y is 10, just to verify, and our X is 10. So this is what we have done. So what happened to 102 when divided by 100x? So this 100 cancels with 100. There are two x's, x times x, and divided by x. So x times x divided by x remain with 1x, it cancels. 100xy, when you cancel this, and that will remain with what? Y. Is that clear? Great. So this one, please memorize with terrible exactness. I'll be glad if you're able to think in these lines. So let me take you to the exam on utility. Of course, that one was a little bit tough. If this man really wants to wire you, for sure he can wire. So we ought to be. All right. So question number 5, what would be the implication if indifference curves intersected each other with the aid of a diagram? Ideally, indifference curves would need to look like this. Now, if they came out like that, I explained this. What would be the implication of indifference curves intersecting each other? Who wants to try? What would be the implication of the indifference curve? So it would violate a lot of laws that we've talked about on the properties of indifference curves. Those laws to do with, number 1, transivity, which is a vital assumption under the intersection of indifference curves. So it means that indifference curves are not transitive. So remember we said this nature of indifference curves being like this. Simply implies that this indifference curve 1, indifference curve 2, indifference curve 3, this one has a higher utility. For instance, this is 10, this is 15, this is 20. So if indifference curve that has 20 and difference curve that has 1, they don't, it's like in the way the army is arranged. Okay, the army is arranged the way that they never even mingle with the junior officers to drink with them, unless it's a church gathering. Okay, so this, if it came and cut there, so it means that this is offering 20 utils. At some point, it's meeting at some point, they're offering the same utility, which kills the law. So it violates transitivity, it violates consistency of preferences. When they're intersecting, it would imply that preferences are not consistent and well defined. So here, it means up to some point, your preference level will go higher. As you go higher, you are leaving the preference below you. So going back there defies the law of what? Consistency. Then also the ambiguity that is imbued in utility maximization. When they're intersecting, it becomes challenging to determine which is the optimal point, since we know that optimal point is used to select the highest indifference curve that touches the budget line. If they are intersecting also, it's difficult to predict consumer behavior because intersecting curves make it harder for economists to accurately predict consumer behavior. So in a nutshell, they don't need to crisscross because there'll be a lot of laws that will be in violation. Okay, in reality, the occurrence of intersecting indifference curves is not consistent with the standard of the assumptions of rational behavior, where we know that economists rely on assumptions, and the assumptions of non-intersection are used to analyze the consumer preferences and to predict their choices based on these assumptions. So they should not crisscross. In short, it will violate a lot of laws. All right. Then turbo like spare ribs R and fried chicken C. The utility function is given by 10 RC. What is the marginal utility of spare ribs function? So marginal utility of what? Spare ribs. This man is intelligent. However you copy this question, you need to understand that you're differentiating the U over the what? The S. Whatever possesses U and you forget all this. So our spare ribs are denoted by what? R. So let me use R there. So which one is our dummy? This function is the same one we are just from doing. They just used other letters there. 10x squared C. Remember, we're just from this function. So if you please impress me, as you write your exam, it's not all about you. I'm also in the gap standing, wondering what you guys are writing. So what is the marginal utility of spare ribs? Can somebody do this for me?
20C.
The U over the R. Our dummy is what? There's a 10 here. Okay?
Yes, so it's 20C.
20 RC. Do you agree with her? So what is the marginal utility of what? Chicken therefore? Now dummy is that? R2. So we're going to remain with 10C. The derivative of 10C is 10. All right. Are we together? 3 max. 3 max, sure. 7, 6 max already. My people perish.
Mr. Collins, this one came as a multiple choice, eh? They also asked in the multiple choice.
In the test, yes.
I think for the last semester,
For the test,
the
yes.
one for the spare ribs.
It came in the test, yes.
Okay. Okay.
So it has ended there. Then this one here, 10 max. The one from doing. This one, you've seen it, right? Have you seen the one we're from doing?
Yes.
We don't need to do it again. Then Chimuka loves shoes and is going out to dance. Here, the utility function of shoes S and the number of times she goes dancing T is given by the utility 2ST. If Chimuka, it costs her 50 kwacha to buy a new pair of shoes, so 50S, and costs to spend, so it costs Chimuka 50 kwacha to buy a new pair of shoes or spend out an evening dancing that she has 500 kwacha to spend on clothing and dancing. What is the equation of her budget line? Draw it sharp. So the time spent on dancing, 500. What is the equation of the budget line? So let's analyze this. Let's analyze this. So this, I put it already in the pamphlet. Who wants to try?
We have been given an income of 50 kwacha. And then we are supposed to split the 500 for both the clothing and the dancing, the 500 kwacha.
Okay.
When we split, we have to create a budget line based on that amount, and it should be equals to 50 kwacha. That's how far I can explain it.
Okay. Anyone else? Yeah, very right. So we just need to come up with understand the concept here. Chimuka has two options: shoes and what? And time to go out and dance. So we use T as time on the vertical axis. Okay. So time to dance, T. So meaning shoes, S. At least that we can establish. Then what else are we taught? The utility function is given by U is equal to 2ST. U is equal to 2ST. And what else are we taught? We're also told that it costs Chimuka 50 to buy a new pair of shoes or to spend an evening out dancing. So assume she has 500 to spend on clothing and dancing. What is the equation? Okay, so what is the equation? Income is got what? Price of shoes times S plus price of what? Dancing and pleasure times T. The budget we have is 500. Then shoes are costing what? 50. And price of parting are not given. So time S is 50, 500 over what? 50. This one can be computed as 10. And this one will be 500 divided by what? Price of parting, PT, which are not given. So it can be left as an equation unless we're given the price itself. Okay. So label and the slope and the intercepts. So 4 marks. So we know the slope is equal to what? Price of X. Our X this time is what? Our S here. And price of time for dancing. So 10 over what was the price of shoes? 50 over price for parting, PT. So this is a function that cannot give you an absolute figure. All right. So fall back. What is the equation of the budget line? Draw it and label the slope and the intercepts, which we have done. Okay. So question number 4. Number 6, we go to our isoquants. So mention what we understand by the term isoquant and 4 properties of isoquants. So isoquants are very similar to indifference curves. What are isoquants? And what are the definitions of isoquants? These are lines that join points that offer the same production. They're called isoquants. So in the field of economics, we have combinations of inputs that offer the same level of production. So these are called isoquants. So we're going to look at the properties of isoquants as follows. I must mention that isoquants are very closely related to what? Indifference curves. So here, we've defined first of all what isoquants are. We said isoquants refer to combinations that yield the same level of output in the production process. These are combinations of capital and labor that, if combined, will yield the same. So here we have capital, here we have labor. So we have isoquant 1, isoquant 2, isoquant 3. So the properties are number 1, they're downward sloping. Number 2, they're convex to the origin. Number 3, they don't intersect. Number 4, the isoquants on the right side offers higher production than the one below it. You must understand that isoquants are optimal at a point of tangency, where the marginal product of labor over the wage is equal to the marginal product of capital over the rent on capital. The budget line cost is equal to rent for capital plus wages for labor. So this is just the same optimization problems we're looking at, except that this time they're applied in production. Now, what is production? Production is a conversion of raw materials in terms of labor and capital into output, which is Q. So the Q stands for the total product of labor. Total product divided by the labor units is called the average product. Change in total product over change in labor units, we call this the marginal product of labor. When you multiply the marginal product of labor times the labor units, we call this the marginal revenue product, the value monetary of these units of labor. So let's assume you have 10 laborers, and the average of each of these 10 laborers is 1,000 units. So part A, what is the total product of labor for these 10 laborers? So just cross multiply. Total product of labor over labor, and cross multiply here, the total product of labor is simply the average product of labor times the labor units. So 10 times 1,000, we get 10,000. So if one laborer is making 1,000 and there are 10 of them, the total product is 10,000. Now suppose an additional unit of labor wants to join them, and this one is bringing additional 900 units. Anything additional is called marginal product. What is our new total product? So we are now 11. So 10,000 plus 900, we're going to get the new total product, which is 10,900. Part C, what is the average product of labor now for these 10 laborers? So it is 10,900 divided by what? Not 10, but 11 now. So we get 909.09. Part D, if this new laborer at a market price of 2 kwacha is asking for 2,000 kwacha, is it worth being employed? So we need to calculate the marginal revenue product to calculate the value of these units of 900. How much are they worth? Multiply by the market price of 2 kwacha, which you'll be given in exams. So meaning these 900 units is bringing to us are worth 1,800. So the rule is that we only employ somebody who brings more than we pay them. Marginal revenue product must be more than the wage. So 1,800 is less than the 2,000. So we say this person is uneconomical. It will be a total loss to employ this person. Graphically, or using a table, you would be given units of labor, maybe 1, 2, 3, 4, 5 units of labor. Then the total product, maybe you're told that here we have 10, we have 14, we have 21, we have 16, we have 10. So this is the total product of labor. According to our formulas, how do we find the average product of labor? We divide the total product of labor divided by what? The number of laborers. So 10 divided by 1 is 10. 14 divided by 2, 7. 21 divided by 3, 7. 16 divided by 4, we have a 4. 10 divided by 5, we have a 2. Then they also ask us to find the marginal product of labor. So here, if the difference is 1, then we are good to go. So the difference from nothing to 10, we don't know. But from 10 to 4, what is the difference? 4. From 4 to 21, what's the difference? 14 to 21, what's the difference? 7. From 21 to 16, what's the difference? Negative 5. From 16 to 10, what is the difference? Negative 4. So suppose we are told that the price is 10 kwacha throughout. 10 kwacha. What is our margin revenue product? It's a marginal product times the price. So here we have 40 We have 70, -50, and -40. And suppose that we are given a wage. A wage is also called the marginal resource cost of 70 kwacha. So how many units are viable to employ? Okay, so sometimes we ask how many laborers are to be employed for us to maximize employment. We choose where the marginal revenue product is equal to the marginal resource cost. So 70 is equal to 70. So 3 laborers will maximize production, or where marginal revenue product is greater at least. So let me take you to the exam. We're given this table to fill in. We have capital, we have laborers, we have total product. So what is the marginal product of labor? So you go to laborers. If the increment is 1, 1, 1, 1 on throughout, you just see where you're adding on. Here, this is a dash. 5 to 0 to 5 is 5. 5 to 18, 13. 18 to 36, 18. 36 to 56, 20. 56 to 75. What is the difference? 19. In the average product of labor, we are dividing what? The total product of labor divided by labor units. 0 over 0, anything divided by 0 is infinite. 5 divided by 1, 5. 18 divided by 2, 9. 36 divided by 3, 12. 56 divided by 4, 1, carry 1, 14. 75 divided by 5, what do we get? 15. So just filling up this table will give you 5 marks. It's all based on the important issues I was talking about. All right. So CBSO produces ceramic cups using labor clay. She manufactures 25 cups a day with 1 worker, and with 2 workers, 35. What type of returns to scale? Illustrate your answer. So we have 3 returns to scale. We can explain the aspect of returns to scale even graphically. So these curves that are joining points that offer the same production are called isoquants. So if you are moving from 10 to 20 to 30, these are called constant returns to scale. We're increasing at a constant continuum. 10, 20, 40, we are doubling. This is called increasing returns to scale. This is 10, 20, 25. It's increasing, but at a decreasing rate. Here the difference is 10, here the difference is 5. Maybe the difference will be 3 later on. This is called decreasing returns to scale. So you need to understand what returns to scale you are operating. So we are told that this guy has 25 cups for 1 worker. So 1 worker gives what? 25. So obviously 2 workers should give you 50. But in this case, 2 workers are giving you 35. So this is a decreasing returns to scale. Decreasing returns to scale. So you can illustrate that using a diagram. You can also further illustrate that with your own notes to add up. Okay. So are we on the same page? I'm trying to open the pamphlet. So everything is already there in the pamphlet.
Reference.
Yes.
I wanted to find out, you said that after we found average product and marginal product, you said the other step was what? You said MRP, what was that? And then you said we should multiply by output, and then, is that what you said?
Which one? This column, marginal revenue product.
Yes.
When we apply the price times the marginal product, we get this marginal revenue product. It's a value of the additional units you have. Then you compare them with the cost, how much you're paying them. So ideally, you should be able to pay less than you are earning or equal to what you're earning. So when the marginal revenue product is equal to marginal resource cost, then that is the optimum point of employment. So meaning you go, how many laborers we have? We have 3 laborers. Okay, so I'll end here. So
Thank you. And then, sorry. I just want to screenshot the solution for the dancing. What you call this one? I think that should be because it's a utility function.
Yeah, it is.
For the one that we had to do the budget line, and
Okay, it's here.
where those 50 kwacha.
All right, my next session will be on game theory. I only have 3 sessions with you, then I call it.